Hi everyone and welcome back to the Pipex YouTube channel. In this video, we'll discuss an important topic, building information modeling in plant engineering and industrial piping design. When people hear the word BIM, they often think about buildings, architecture, structural design, MIP coordination, clash detection, and construction planning. But BIM is not only about buildings. In plant engineering, process piping, industrial facilities, and fabrication workflows, the same basic idea is becoming more and more important. We do not work only with drawings anymore. We work with information-rich digital models. And this raises an interesting question: how does BIM work in industrial piping design? And where do formats like IFC and PCF fit into this process? That is what we will discuss in this video. BIM stands for Building Information Modeling, but the most important word here is not building, it is information. BIM is not simply a 3D model. A 3D model only shows geometry. It shows what something looks like. A BIM model connects geometry with data. For example, a pipe elbow in a BIM model is not just a 3D object. It can contain information such as material, diameter, pressure class, weight, manufacturer, specification, installation data, cost, and maintenance information. So we can think about the development like this. First, we have 2D drawings. Then we move to 3D models. And finally, with BIM, we connect the model with a database of useful information. This is why BIM is often described as a cooperative working method. It helps project participants create, manage, exchange, and reuse data throughout the life cycle of a facility. In BIM, we often hear about different dimensions. 3D is geometry. 4D adds time, scheduling, and installation sequence. 5D adds cost information. For example, in piping design, a component can have not only its shape and position, but also delivery time, installation duration, material cost, and fabrication data. This is where BIM becomes really powerful. It connects design, planning, procurement, construction, and operation. For plant engineering, this is very important because industrial projects are data-heavy. A plant model must coordinate piping, equipment, steel structure, instrumentation, supports, access areas, maintenance space, and many other disciplines. There are different ways to use BIM. In closed BIM workflow, project participants usually work inside one software ecosystem or rely mainly on proprietary formats. In an open BIM workflow, different participants can use different software tools, but they exchange information through neutral or standardized formats. One example of such a format is IFC, which we will discuss later in this video. There is also a difference between little BIM and big BIM. Little BIM is usually limited to one discipline or one company. Big BIM means that multiple disciplines and companies are involved in a shared digital process. So, Big Open BIM is the most collaborative approach. Different disciplines, different companies, and different software tools exchange project information through neutral data interfaces. This idea is very important for plant engineering because no single software usually covers everything perfectly. One team may work in Revit, another team may work in Plant 3D, and another team may use Aviva, CADmatic, Smart 3D, Cesar 2, Autopipe, or isometric generation software. The challenge is, how do we exchange data between all these tools? The most well-known open BIM format is IFC, or Industry Foundation Classes. IFC is a standardized data schema used to exchange BIM data between different software applications. It can describe objects, properties, relationships, systems, spaces, and other information about a build asset. In building projects, IFC is widely used for model exchange, coordination, clash detection, model checking, and handover workflows. For example, an architect may export an IFC model from one software. A structural engineer may use another software. A map engineer will use another tool. And all these models can be combined in a coordination environment. This is the classic Open BIM idea. Let me quickly show you how you can export a Revit project into an IFC format. You can go to File, Export, and here you need to select IFC. Then you can specify the folder where your file should be saved. And you can modify setup. For example, I could select IFC4 reference view building service. And then all I need to do is click export. But in plant engineering and industrial piping design, IFC is not the only exchange format we need to discuss. There is another important format, PCF. PCF means piping component file. PCF file is a text-based data file that describes a piping system. It can include pipe routes, components, coordinates, sizes, materials, specifications, and other information needed for downstream piping workflows. While IFC is a general BIM exchange format, PCF is a specialized piping exchange format. Unlike IFC, it allows information to be seamlessly integrated into other software platforms. PCF is commonly used to transfer piping data from a 3D model into software that generates piping isometric drawings, material lists, pull drawings, or stress analysis input. This is very important in industrial piping because isometric drawings are still one of the key deliverables for fabrication and installation. A piping designer may create a 3D model, but the construction team often needs isometric drawings, weld lists, cut lengths, material takeoffs, and spool information. You can say that PCF helps connect the 3D piping model with these downstream deliverables. And now I would like to show you how you can export your Revit project information into a PCF file using Pipex export plugin. All you need to do is go to Pipex, login, go to Systems, select the system you need, and click Export. Next, you need to specify location. I'll select Desktop and click OK. Is it correct to compare IFC and PCF? Well, actually the answer is no. You can compare these two formats only if you do it carefully. They are similar in one sense. Both help exchange information between software applications, but both are different in scope, of course. IFC is broad. It is intended for BIM data exchange across many disciplines and lifecycle use cases. PCF is narrow. It focuses on piping systems and is mainly used for isometric, fabrication, installation, and sometimes stress analysis workflows. A better way to explain it is IFC supports general BIM model exchange. PCF supports a specialized piping production workflow. In plant engineering, both can be useful. IFC may be used for coordination and model review. PCF may be used for piping isometrics, fabrication data, and stress-related workflows. So the discussion should not be IFC versus PCF. It should be IFC and PCF, different formats for different purposes. Revit is one of the most widely used BIM authoring tools, especially in building and map projects. However, for industrial piping design, Revit has some limitations. One important limitation is PCF export. Native Revit PCF export is connected to fabrication parts. That means standard Revit piping elements and custom piping families are not always easily transferred into a PCF-based industrial piping workflow. This creates a gap. I'll give you an example. A team may have piping models in Revit, but downstream tools may require PCF for isometric generation, pipe stress analysis, or fabrication documentation. So the question becomes, how can we move Revit piping data into the plant engineering toolchain? This is where a PCF export plugin for Revit becomes useful. A Pipex PCF export plugin can help export piping data from a Revit model into the PCF format. That PCF file can then be used in PCF-aware downstream tools, for example, tools for isometric drawing generation, stress analysis, or plant design workflows. This way, a PCF file and the Pipex export tool supports one very important Big Open BIM principle. Data created in one software environment can be reused in another software environment. For industrial piping, this is extremely valuable. The piping model should not be trapped inside just one tool. The data should be reusable for coordination, isometrics, fabrication, stress analysis, and project documentation. So, we can say that a PCF export plugin for Revit supports a Big Open BIM-oriented workflow in industrial piping by enabling cross-software data exchange through a specialized piping format. And we come to our 3 takeaways. Plant engineering is multidisciplinary by nature. A plant's project includes process, piping, mechanical equipment, civil, structural, electrical, automation, procurement, construction, and operation. Each discipline may use different software. This means that data exchange is not optional. Today, it is essential. If we cannot exchange data, we lose time. We manually recreate information, which leads to redundancy. We create the risk of errors, and we break the connection between design and fabrication. Built-in information modeling helps solve this problem by treating the model as a source of reliable project information, also called single source of information. But in plant engineering, BIM must respect the reality of specialized workflows. That means we need both general BIM formats like IFC and specialized engineering formats like PCF. So, what's the role of BIM in plant engineering and industrial piping design? Building information modeling helps us move from disconnected drawings to information-rich digital models. In building projects, IFC is one of the main formats for open BIM collaboration. In industrial piping, PCF plays an important role as a specialized exchange format for piping systems, especially for isometrics, fabrication, installation, and stress-related workflows. IFC and PCF should not be treated as identical formats, of course. No, I never said that. But both support the same general goal: better information exchange between project participants and software tools. And when a Revit PCF export plugin allows piping data to move from Revit into PCF-aware downstream applications, it supports an open, cross-software workflow for industrial piping. This is why BIM in plant engineering is not only about 3D modeling, it's about connecting people, data, software, and deliverables across the whole project lifecycle. If you work with BIM, plant engineering, Revit, PCF, or industrial piping design, let me know in the comments, do you use IFC, PCF, or maybe even both in your workflow? And what is the biggest data exchange problem you face in piping projects? Thanks for watching, and see you in the next video.